Welcome to the 8th grade math homework helper series. Tonight's homework is scientific notation and word problems. We're going to start by taking a look at problem number 1. The speed of light is about 3 million meters per second. Write an expression that shows this speed in scientific notation. So the first thing we need to do is to capture 3 million and put it down here. Then we need to determine where the decimal is and where we want it to go. The decimal is currently sitting right here. In order for it to be in scientific notation, remember the decimal has to be in a spot where you're going to get the number that falls between less than 10 and equal to or greater than 1. So we have to determine how many times is the decimal going to move to go from where it is now to where we want it to be. So let's count the moves. And as we move the decimal, we see it moves 8 times. So now that we know that it's going to have to move 8 times, we can now write that number in scientific notation. And we show it as 3.0 times 10 to the 8th. And don't forget to include your meters per second. You have to have a unit of measurement attached to your answer because there was a unit of measurement in the word problem. Okay. Let's take a look at the next question. Question number 3. Without converting the numbers to standard form, which means we have to leave them in scientific notation, explain how you know which one is greater. Well, this one we can solve in one step, and we really just have to look at the exponents. We need to see which number has the bigger exponent, which base 10, and that's going to tell us which of these is really greater. Now, with negative numbers, negative 6 is going to be bigger than negative 7. So I can tell without converting that 8 times 10 to the negative 6 is larger than 9 times 10 to the negative 7th. Let's take a look at question number 6. For number 6, Lily wrote the problem below in her notebook and solved it. Did Lily solve the problem correctly? Explain why. So the problem was 2.0 times 10 to the negative 5th and 3.0 times 10 to the 8th. Lily's answer is 6.0 times 10 to the 13th. Let's break it down and see how Lily did. The first thing we can do is check Lily's multiplication. Does 2.0 and 3.0 equal 6.0? Yes, it does. So far Lily is correct. Now let's check what Lily did with the exponents. It's multiplying, so Lily should have added the exponents. Does negative 5 plus 8 equal 13? Well, no. Negative 5 plus 8 equals 3. So what mistake do you think Lily may have made? Well, I'm guessing that Lily ignored the negative sign when she added the exponents, because 5 plus 8 would have been 13. So you can write that in as she ignored the negative sign when she added the exponents. Let's move on to the next page. We're going to take a look at number 7. Number 7 states that the mass of Mercury is about 3.3 times 10 to the 23rd kilograms. The mass of Jupiter is 1.9 times 10 to the 27th kilograms. About how many times is the mass of Mercury more than the mass of Jupiter? Well, the first thing we want to do is take the numbers that we have and put them over one another. So we have 1.9 times 10 to the 27th over 3.3 times 10 to the 23rd. And then let's break them up so that we have numbers over numbers, and because we're dividing, we're going to subtract our exponents. As we solve that out, when you divide 1.9 and 3.3, you're going to find that the answer works out to be 5.57575757, and it goes on for an extended period of time. So we can round up, since the third digit is a 5, we can round that 7 up to an 8 and just leave it at 0.58 times 10, and then we subtract 23 from 27 and we get 10 to the 4th. Now, if this number were in correct scientific notation, we could stop right here. But unfortunately, 0.58 is not between equal to or greater than 1 and less than 10, so we have to move it. And the way that we do that is by shifting the decimal one place in, thereby making it 5.8, and we have to multiply it times 10 to the negative 1 times 10 to the fourth. And if we go ahead and do our subtraction, our addition, excuse me, because we're multiplying now, if we add those two exponents, we get 5.8 times 10 to the third times the mass of Mercury. And our last problem, problem number 9. For problem number 9, the speed of light is about 3 times 10 to the 8th meters per second. About how far can light travel in 2 hours? Well, the first thing we need to think about is what is the unit of measurement we're talking about here? Meters per second. So we're going from seconds to hours. So we're going to need to convert that. How many hours are there? How many seconds are there in 2 hours? Well, there are about 7,200 seconds in 2 hours. So 7,200 is the number we're going to want to work with, not 2 hours. So let's set up our problem. We have 7,200 that we're going to multiply by 3 times 10 to the 8th. And if you multiply 3 times 7,200, you're going to get 21,600, and we bring down times 10 to the 8th. But we know that our decimal is actually right there. And we know that we want to put it right there. So how many moves is it going to take to go from where it is now to where we want it? Well, let's count those moves. It's going to take 4 moves to put the decimal where we want it to go. And if we rewrite it that way, we're also then going to have to add 10 to the fourth for the 4 moves that we made to the 10 to the 8th that we already had. And when we put that together, adding those two exponents, we get 2.16 times 10 to the 12th. And again, you need to make sure that you include your unit of measurement, in this case, meters per second. Please use the problems that were done tonight to help you with the additional problems on your homework. Remember, the key to math is not only working hard, but working smart.